Okay, hello all. In this video, we will talk something about the examples. We will do it by SAS. SAS stands for sine, angle, sine. And the angle must be the middle or must be the include angle between the two sides that are given to you. So let's look at the teaching example 9.6. You are going to have that we have three triangles there, and now you are going to find out that which two triangles are congruent together. So first of all, okay, let's find out these two triangles. For example, we have 4 and 5. Obviously, we have 2s. So we must choose the one that which is in the include angle. So let's look at this. 4, 4, 4. And then we also have 5. We also have 5, 5, and 5. So that means we are going to find out the include angle. If I choose this orange and red side, that means the only include angle is the one in the middle. So between this orange and red is this green one. This green one, 55 degree. And this one is the green one, 55 degree also. But for this one, if we the orange one and the red one, the include angle will be angle Y, but not angle Z. So that means, unluckily, we can only choose the two triangles PQR and WUV. So why don't we follow it? This is PQR from orange to red. Why do we have WUV? So that we can have in triangle. So okay, to prove it. Okay, let's write down in triangle PQR, orange to red, orange to red, and WUV. Okay, these two triangles. Okay, now let's write one by one. For S, this is PQ is equal to 4 cm. We know it this is 4 cm and equal to WU. Okay, this one is given. I give it to you there, 4 cm. You can write the 4 cm in the middle. It's much better, 4 cm. Okay, you can write something like this. And then we know that angle PQR is equal to 55 degree. And also it equal to the angle WUV given. So finally, we will have QR will equal to 5 cm equal to UV given. That means we have SAS. Okay, so we can say these two triangles are congruent. Triangle PQR is congruent to triangle WUV SAS. This triangle cannot be congruent with these two because the include angle does not given. If I can say this one is 55 degree, I can say these three triangles are include angle. Okay, but it may not be possible. So we can say this is the proof for teaching example 9.6. And now you are going to distinguish which two triangle can be congruent. So this is your time. Okay, now I give you 1 minute to do this question. Okay, now if you cannot finish, just pause the video and I will show you the answer now. Obviously, you can say that the 70 degree is between 5 cm and 6 cm for DEF and also the PQR. The only 7 degree is not between 5 cm and 6 cm, this ABC. So ABC, I will not make it congruent. So these two triangles are congruent. So why don't we write it out from the side and cosine EDF, okay? Triangle EDF and triangle RPQ, RPQ, okay, so that we can write this triangle. Okay, immediately we can write 5 cm first. ED is equal to 5 cm is equal to RP given, and next that will be angle EDF equals 70 degree equals angle RPQ given, and finally that one will be DF equals 6 cm equals PQ given once again. So we can say these two triangles are congruent and we call them SAS. Okay, so this is the proof of the correct practice 9.6. Every time we have 5 rows. Okay, now let's do the teaching example 9.7. Okay, now let's look at teaching example 9.7. Okay, now in the figure you will see AB equals CD equals XCA, and you have two angles. And then are they congruent? The answer is that yes, but how can we prove? So first, most of the time we say that yes in proving congruent. This one is AB, this one is CD. Okay, AB and CD. We have the first condition, and we know that the 30 degree we must know is this condition. The second condition is the degree SA, and which one is the final one must be S, so that then one that to make this 30 angle. So we will choose BD for triangle ABD and DB for triangle CDB. So obviously they have two same side. So I think that these two are common side. So we will use the condition common side, the reason to prove that they are congruent. So let me write it down for you all. Okay, first of all, yes, I can say in triangle ABD and triangle CDB, we can write something like this. And we write one by one. For AB is equal to XCM equals to CD given. This one is S. Next one, I write down angle A. So this one is angle ABD is equal to 30 degree equal to angle CDB, also given. Okay, we have the second one. The last one we will choose is BD is equal to DB. This one is called common side because they are the same side, so obviously they will have the same length. So we can say this triangle ABD is congruent to triangle CDB. We call it SAS. So now this will be your turn to do the correct practice 9.7 by yourself. That will be triangle ABD and also triangle ACD to prove that they are congruent. Okay, so I will give you 1 minute to do these questions. Okay, now if you cannot finish, just pause the video now. Okay, I will tell you the answer. In case you can see AD are overlapped, so this one is the common side. We have right angle here. That means the other one must be right angle also. 90 and 90, that's adjacent angles on straight line. We have BD equal to DC. That means these three is SAS, not RHS, because we do not give you AB or AC. So that means yes, once again, in triangle ABD and triangle ACD. Okay, these two conditions. We can say one by one. For example, let me write down AD equals AD first. This is common side. This is the first conditional S, and then the A included is ADB equals ADC. Angle ADB is equal to angle ADC. That one must be given. Okay, last one will be BD equals to CD. So this one is also given. Because in the question, we have already have these two conditions so that they are given. Okay, don't just write given that I have never given it to you. Given it to you. Okay, so choose the one that I gave it to you in the question. Okay, finally, triangle ABD is congruent to triangle ACD. The answer is once again SAS, so that we can prove the question like this. Okay, thanks for watching in this video, and bye bye.